Hello, everyone. Thanks for joining us today for building embedded software efficiently with an IDE our series. I'm Teresa Kisha, and I'm your host today. With me today is Maciej Halasz, Vice President of Technology here at Timesys. Maciej heads up our EMEA office and will be the instructor for today's session as well as for the remaining sessions in this series. Today we continue with Session 2, Application Development and Debugging with TimeStorm. This event will be recorded and available following this session so that you can view it again at a later date if you like. You can use the same link that you're using to watch this live session to view the post-event recording. In addition to that, I will be following up with everyone via email within about 24 hours, no more than that. I will include a link to the recording again in case you need it, as well as a download link for today's presentation and a download link or link to view the Windows 10 document. And now, without any further delay, I'll go ahead and hand the controls over to Maciej to get things started. Just want to thank you all again for joining us, and we hope you enjoy today's session.
Thank you, Teresa. Welcome back, everyone. Today, we're going to cover Session 2 in this series on developing embedded Linux software with an IDE. And the focus of today's session is application development and debugging. Thus, the slide announces that. What is important when developing applications? What do I need to write embedded Linux application code? So this is the first question that we're going to tackle today, followed by the languages. In the embedded Linux development, as application developers, we oftentimes search for different ways of writing code and meeting requirements. So we'll talk about the most popular languages that we see in embedded Linux. Which tools would be of most use? There are many different utilities that embedded Linux provides, and we have to always carefully choose which ones are going to do their work well and fast. And we're going to take a look at it from, of course, the application development perspective, but also from the perspective of an IDE. And then finally, a question that as application engineers we oftentimes ask: which APIs do I need for my development? How do I identify APIs in the first place? And how do I make sure that they're available for me in the IDE? So these are some of the questions that we're going to tackle today. And the first question is, what do I need to develop apps for Linux? The picture that you see right now represents a development environment as supported by us. You can see a build environment, which is powered by either Yocto build system or another build system. We offer also a factory build system, but that side is still associated with system-level development. What that produces are several pieces which are important to us as application developers today. Piece number one, it's something called Software Development Kit. Piece number two, Board Support Package. And piece number three of tools and software that we're going to use is the IDE itself. The Board Support Package is something that gets deployed on the actual hardware that we're going to work with. Today, for hands-on part, we're going to employ IMX6. Devices boards, I believe that's the one that I have connected to my machine today. Development kit is something that we install on our host, something that in the last session I showed you how TimeStorm auto-recognizes software development kits, so that's what it is, and of course TimeStorm. which tools and languages are most useful in embedded Linux. So when we look at programming languages, when we look at the Linux kernel itself, it's written primarily in C and assembler. There are, of course, all over the Linux kernel that help with the configuration and build process, but primarily programming perspective at C. For application development, we have quite a few choices. The most popular, C++. C, it's actually one of the first languages that have been created for more complex applications. Was designed in the 70s by Dennis Ritchie at AT&T Bell Labs, or intended for embedded use back then. Today, C remains the most widely used embedded programming language, with compilers available for almost every microprocessor, microcontroller, and processor core on the market. The C++ has been designed by Bjorn Strostrup, also of Bell Labs. It's one of the key factors in the success of C++ was its initial implementation. Instead of writing a conventional compiler, Strostrup wrote a preprocessor, the C-front, that translated C++ into standard C. This means that the language was ready for use just about anywhere a C compiler was available. Special C++ compilers are very common and used in GNU as well. It's very popular nowadays. It's Java. Java was developed by James Gosling at Sun Microsystems, now part of Oracle, and released around 1995. Gosling's original concept was the creation of a robust language that could be used to write portable applications. That concept, of course, evolved over time, and Java has been nowadays employed in many, many different embedded situations, and it's a primary programming language for Android operating system. Actually, part of Android is also Linux, but application programming is happening, of course, in Java. Next one is JavaScript. Was developed at Netscape, also in the 90s. Its name is confusing because it has no real connection with Java. The selection of that nomenclature was a marketing matter. The language has a C-based syntax, but it also has a number of features that are different from other C derivative languages. Last one I'm going to mention today is Python. It also appeared in the 90s, created by Guido van Rossum. It is thought of as a scripting language, but it's very powerful, powerful enough for much more sophisticated programming applications. Syntactic elements from C, but is less like less C-like than other programming languages that we've mentioned earlier. Okay, dialects. What are the dialects? Dialects are revisions of the C language spec standard, aiming at adjusting the C programming language specification to accommodate for multi-threaded support, safer standard libraries, better compliance with other industry standards. C language security has always been a matter of concern. There are many, or used to be quite a few insecure features, such as string manipulation functions that don't check bounds, and file I/O functions that don't validate their arguments. These have been tackled by revisions to the specification, and C11 revision, many of those matters. dialect has been introduced in 2014 and is the latest modification to the C language specification and further enhances the C language alignment with other standards. About many different programming languages, and to write embedded applications for embedded Linux, C and C++ are the primary languages. But the C compiler is not sufficient. There are other tools that are part of the cross tool chain which are important. Those tools are typically launched from a C compiler itself, so you don't have to explicitly call a linker. The compiler itself will know that. See pilots out in your contacts. Sorry, there's my iPhone, for some reason, Siri is turning on. My apologies if it disrupted audio. Right. So the SDK, the software development kit, provides us with libraries and header files, which are the APIs that we can leverage to develop our software. But the cross-tool chain that's also part of the SDK provides these different tools that I've mentioned earlier in the slide. So we not only have a C compiler, we also have a C++ compiler. We have an archiver to create a static library. We have assembler. We have debugger, which we are going to be using today. The GDB stands for GNU Debugger. We also have other utilities to manipulate object files and some helper utilities that strip some of the binaries from unneeded symbols, for example. So all of these utilities typically are installed in or as part of the cross tool chain that's available with the SDK. Okay, so that's precisely what we're going to be using. Let's continue. Which APIs for development? When we start our application design, we always think of the specific use case that we're going to have. So I picked one industrial control panel application, which would have some web services, would have a UI that would show up on an LCD display. It would have auto-launching, overlays, network connectivity. So these are the high-level requirements that translate into a set of APIs that I would like to leverage in my application development. Those APIs in the embedded Linux, they live in a file system, and they're also commonly referred to as middleware. Those APIs as middleware are typically provided to us as part of the software development kit as well. So the middleware lives on the target system in a root file system that's executed at runtime. So that's where we want to have the shared libraries. And the same shared libraries and the matching header files are pre-installed in the software development kit for us as application developers to be able to leverage those APIs definitions rather than writing everything from scratch. So this is the perspective of the application developer when we design our application software. To complete the overall system architecture for Linux, I'm going to add these other layers where we have Linux kernel, where we have bootloader, and of course processor. And those different APIs provide means to access underlying hardware through appropriate device drivers in the Linux kernel. But again, as application engineers, we are focusing on the red and light green colors. So today we're going to have a little bit more of hands-on compared to session number 1. But before we switch to the hands-on part, I wanted to introduce how TimeStorm projects. How do we start a project in TimeStorm? the easiest way is to leverage one of the project wizards. They offer great accelerating point in setting up of a C or C++ project. And they are available not only for C, C++ project, but also for static and dynamic library. And although we're not going to be talking about it today, there are specific wizards for setting up of a Linux kernel or a device driver. We also have a dedicated wizard for CMake type projects, something that I'm going to show you today for sure. All wizards that TimeStorm provides are optimized for embedded Linux development. What does it mean? Well, they have specific fields that tie the project setup with the software development kit. So at some point, the wizards are going to ask you, tell me which software development kit you would like to use. Starting any embedded C or C++ project with TimeStorm is very easy. I'm going to show you that firsthand. Application that we've developed, we typically want to run, execute, and debug that software directly on our target system. And to facilitate the communication with a target, TimeStorm provides a plugin called Target Management. It is also a very well optimized plugin that asks only the necessary questions to help you set up the communication that's necessary for deployment and debugging of Linux application on a target. And as such, it supports different communication protocols. The most common one is Secure Shell for remote access, and the matching Secure Copy for file transfer. But it also supports other ways of deployment, such as FTP or network file system. Once you enter all the necessary information in a wizard, you're going to be presented with a check link button, which will verify that your connection is live. And you do that once per target setup, and that connection will become available at various stages of our development. So you define the target once, and it becomes available for deployment, debugging, optimizations. So we're going to use that feature today and for our next two sessions. The Target Management plugin allows us to work with multiple hardware targets. Switching between the different targets is very easy. You just pick a different target from a drop-down menu. All the complexities of working in a cross environment are this way hidden. And it feels as if you are developing your software for a local machine, but in fact, you are developing for the target system. Deployment configuration. Another assist with getting the software that we've developed to the target is to define a configuration for deployment. And TimeStorm offers dedicated deployment configurations for applications, for libraries, for kernel, for many different types of projects. Those deployment configurations allow you to control fully the target environment application configuration. What does it mean? Well, sometimes we want to export certain environment variables to the target, something that's not exported as part of the system boot time. But our application counts on it. A very common environment variable that graphical applications rely on is a variable called display. And the deployment configuration allows you to configure those environment variables and export them before you launch your application. You can also specify different parameters to your application, not one, but multiple. So however many parameters your application is supposed to take, you can in one of those deployment configuration screens. The deployment configurations are also integrated with and the target manager. So in the deployment configuration, I want to be able to pick the target from the drop-down menu, and I want to be also able to work with appropriate when I'm launching a debug session. Through those deployment configurations, I can launch or debug software on different hardware targets with different options. So I can have 2 or 3 different boards in network configured with different system settings, and I can verify my application, not only run, but also debug it on those different targets very easily. Deployment configurations are there for. Application debugging. Application debugging in a cross environment, typically if you were to do this by hand, you would have to, every single time you start a debug session, you would have to manually set up the launch process, meaning I have to launch the application on a target, start some sort of front end to that debugger, connect to the target, establish that connection, load the symbols, debugger, and then I can start looking at the debugged information one thing at a time. So I can take a look at the registers. I can take a look at variables and IDEs to help us with the process, but also to expose more information to us at once. And TimeStorm does exactly that. It allows us to set up a debug session with clicks. It supports the cross-debugging of different embedded components. So today we're going to experience debugging of C++ application and shared libraries. But next session, we're going to use the same IDE to debug Linux kernel and a device driver. The debugger in TimeStorm supports different modes. And I've mentioned here all-stop mode and non-stop mode. That makes sense for multi-threaded applications. Have a breakpoint, let's say, somewhere in a code, and the debugger hits that breakpoint. In an all-stop mode, all the threads are going to be suspended. The entire application with all its threads is going to stop mode. If other threads don't have breakpoints, they will continue to run, while the thread that has breakpoints set on it is going to stop. Okay, so you have different situations that you can use or debug in with TimeStorm. Sometimes we have situations where our software is running on a target, easy way to launch it again. Or actually, we don't want to relaunch it. We just want to connect to a running application to check its health. TimeStorm allows you to attach to a running process. It's running on a target, doesn't need debugging symbols to be part of the executable, but it needs to have a debug symbol table. That by simply building the application with all the debug symbols built in, and then we strip the debug symbols. That keeps the debug symbol table as part of the executable. We need the full application with all the symbols to be present on our host, where TimeStorm loads those symbols and can make references to the symbol table on a target. The attached to a running process allows you to specific process ID, connect, load the symbols locally into the IDE, and then step through the code. TimeStorm also supports simultaneous debugging of multiple applications and targets. Okay. The process that allows that is relying on a specific port, and by establishing a different communication with the same or different target on a different port, TimeStorm is not going to be confused as to what it's debugging and what is it that it's showing to you. Dedicated debug session configuration allows you to have full control over the debug process. It's very intuitive to debug with TimeStorm. You're going to feel as if we were debugging a local application, but you will see that we are actually on a target system. Okay, so with that, I'm going to switch now to a live system to show you a demo. Okay, so what we have here is my Ubuntu system. And in this Ubuntu system, I have TimeStorm opened. And in TimeStorm, I showed you last time how it auto-recognizes software development kits, how you can download software development kits from Linux Link directly. Today, we're going to start by using a project wizard. So we're going to start with a project. And we have a C++. Let's pick C project. We can select C project wizard. And TimeStorm provides you with several examples that you can start with. So I'm going to pick this multi-threaded C program. And I'm going to call it multi-C program. And it has TimeStorm cross-compile tool chain, which is the tying of the wizard to the SDK manager. It can build executables with different flags. So it can build executables without any debug symbols, with debug symbols, and with additional symbols. So all these configurations are selected. Screen, we are ready to associate a specific software development kit with it. If I don't have a target hardware handy, I can click on Other SDK and I can use the native toolchain for my project. Because I have an IMX system, I'm going to select here a Yocto SDK. And this is an SDK that's matching a board support package that I have deployed on my target. Important to have that match because if the libraries in my development environment differ from the runtime libraries, my application software most likely is going to run into trouble. So it's important to keep that in sync. So I've just associated an SDK and the toolchain with my project, and I can say finish. TimeStorm proceeds, sets up the multi-threaded example as a new project. And now I have here a project which, using the context menu, I can bring the of different actions that I can perform on this project. So you can see clearly build project and clean project. Let's build it. I'm building the project. Project is built, and in the console window, you can see that, well, the compilation GCC invocation, and then there's a linker indirectly called by GCC. It's an executable. I can expand the binaries here. You can see that it is an ARM executable. I can now target. To launch it, I go to run, and there are run configurations. So now I'm going to create a configuration to start this application, this binary on a target. There is several different wizards that allow me to set up different types of configurations for launching this software. We want to select this, TimeStorm C++ Remote. Clicking on it creates an entry for my program. Most of the windows that are stacked on top of each other are already pre-populated with information, but you have ability to add additional parameters here, program arguments. I can export those environment variables that I was talking about. There's also a tab here, download files. So this executable is going to be uploaded to a target. There's one tab here which has a red mark on it, which is and you can see that my drop-down list is empty. Well, I have to first define target. So I'm going to click on this Manage Targets link, which is going to bring up the target management wizard. And it's very straightforward. We click New to give our new target a name. I'm going to call it IMX6. And to connect to our target, I'm going to use the SCP and SSH protocols. So for these protocols, I need to specify the IP address of my target device, also how I want to connect to it. So username and password. When I switch to execute, you can see that by default, it uses SSH, and it took already information that I've entered on a previous screen for download. This is pretty much it. Now I can click on this check link button. You can see that target check is passed. So I do have a live target with which I can work. To show you that I do have the live target, this is the console, and I can show you that this is Nitrogen 6X 4.1.15 Linux kernel. Okay. And this is its IP address. So that's precisely how I define this in TimeStorm. So I introduced this definition once, and now this definition of a target is available for me to pick from the drop-down list. So I've selected IMX6, and I can execute my software. TimeStorm uploads the application to the target, runs it under control of the IDE, and shows the output in a console window. What do I need to do to debug it? Well, there's a separate configuration screen for debugging. It's very similar to the one that we've just seen for launching the application, and the same definition is already there. The only difference is that there's the debugger tab, which has the appropriate debugger selected based on the software development kit that we are using. I don't have to do anything else, just hit debug. And now I can navigate to a debug perspective, which is going to switch the configuration of windows and will show me the windows that I want to see in a debug session. So I have here a editor with a code, and the line where the debugger stopped the software on the target is highlighted. On the top of the screen here, I have those buttons that read step into, step over. So if I click on step over, you can see that the highlighted line. Now, this is a multi-threaded application, so I can place a breakpoint somewhere in the function here. Placing a breakpoint is simple. We just click next to the line where we want to place the breakpoint, and then I can resume the execution. And when the breakpoint is caught, you're going to see it highlighted. You can see here that I have multiple threads already running, each thread on one of the 4 cores of the IMX6, and all of them are suspended because of the container. One of them is suspended because of a breakpoint. That's the one that caught the breakpoint. All the other ones are suspended because there was a breakpoint caught by the first thread. So this is the all stop mode of debugging. I can resume that debug session, and TimeStorm will continue. Well, unfortunately, this breakpoint is set so that every thread is going to catch it, so I will remove it. I'm going to resume. So once the application terminates, the connection to the target terminates. I'm going to very quickly show you another debug process where I'm going to specifically say, debug this software, but in a non-stop mode. Okay, so I want other threads to continue their execution. Okay, so I just started a debug session again with a target in a different mode. I'm going to first hit that same entry program, and now I can set the breakpoint in the same place, and I'm going to click resume. See that thread number 1 is running. Other threads, because they hit a breakpoint. Okay, and I can access the stack here. So where this thread is stopped, here's where this thread is stopped. All of those threads stopped on the same function. If I scroll down, you're going to see that all of these threads are stopped on a breakpoint. So let's resume some of them. We can resume them by simply saying resume. And the moment I hit resume, you can see that that particular thread changes to the running state, whereas all the other ones are still stopped in their breakpoints. Okay. Perfect. On the right-hand side, you can take a closer look at the variables and global variables. You can also take a closer look at the registers of the target system. These are the IMX6 registers. I just expanded the view so that you can see what those registers are and their values. So if I step through this code, you can see that values in certain registers change, and they are all highlighted. This is another way to debug the system. Now I'm going a different type of application. So we've talked about developing just a C code. Let's start with a different project. And we're going to develop a shared library. And there's a template for a shared library. I can call it hello lib. Setting up of a new library is very similar to the setup of application. And now here I can compile this application or library, and I'm expecting that the executable is going to become a .so file, which is precisely what this is. So here we have under binaries lib hello lib.so. Okay, so if I expand the code, you can see that there is a say hello. Let's put this say hello in my application. Gonna say hello here. Hello. And TimeStorm is not going to recognize this function. If I do a mouse over a known function, you can see here, I can clearly see the prototype parameters. The editor tells me everything. And again, this editor supports all the dialects, C99, C11, C14. Them are supported here. But my say hello function is not recognized. Why? Because I haven't included the file. So I'm going to say include hello lib.h. and save this. You can see it highlighted because this project doesn't know about the other project. How do I tell it about the library project? I access the executable project properties, and under CC++ build, there's a set of views called settings, and under tools settings, I have full access to includes, to libraries, and so on. So I'm going to add includes path. I'm going to leverage the workspace, and the include path, I want to be sources. I'm going to do the libraries. So I want this library to be called hello lib. And search path for the library is again going to come from the workspace inside a debug directory. Okay. One other thing that I can do on my executable project, there is something called project references. If I want another project to be built or cleaned together with my project, I can simply check mark it here. So now every single time I'm going to build multi-C program, the library is also going to be cleaned and rebuilt. You see that hello lib is now understood. If I scroll down to say hello, it's recognized. Okay, so let's see if I can compile it. Build project. That's the compilation. And linked against the library that we've just built, and I have the library here. So my executable now has the library. So what happens if I want to run this configuration on a target? I don't have to change the already defined launch configuration unless I want to. But under downloaded files, you're going to find that there's not one, but two files that TimeStorm is going to upload automatically. It's my executable and the library that now my executable wants to use. Okay? So if I click run, both the executable and library gets transferred, and the application runs. Okay. If I want to work, by the way, debugging of that software is no different than debugging of a single application. The debugger steps into the library because it has all the debug symbols effortlessly. Sometimes we want to grab the software from somewhere else. Like, let's say that we use the SCM, and TimeStorm comes with a Git SCM pre-integrated. So I can do a Git View, and you can see that I'm tracking several repositories here. I can navigate to specific Git commit, click on, let's say, a Linux kernel, because that's one of the projects that I'm tracking here. Or actually, there's this Exploring BB, so that would be this one, Exploring BB. I can click on this, and I can see the last commit, okay, on this project. I can also expand at this point the working tree for the project. The CMake type of project. Click on any of these apps, select the history. Now I can see the history of commits per file basis. On the Linux kernel, where you have multiple branches, it's a little bit more readable. So I'm going to show you this very quickly with the Linux kernel. So open git commit. There is one of the Linux kernels. You can see here in history, this view real quick. the history of different commits. And if I click on every single commit, I can find below the description of what that commit is. Okay. I can also select any of these commits, right mouse click. I can do cherry picking. I can do a quick diff. So full integration of SCM into our development environment. Now, any of these projects that we keep in Git through SCM, I can set up as projects in TimeStorm project, and I can say import projects. And at this point, I can import using the new project wizard. Or if I'm keeping Eclipse projects with all Eclipse project files, this wizard allows me to import these directly as Eclipse projects. So once imported, they are going to show up here in a C++, where I can do development, where I can then track the changes, modifications, commit those changes back to SCM, tracking this way that I introduce. Last but not least, type of project that I wanted to show you is the CMake project. Sometimes our applications span different operating systems. We have customers that develop for Windows and for Linux, and CMake can manage different types of build environments. So we can say here, hello, CMake. Very quickly, template CMake project. This is available only on Yocto SDKs, for now at least. But once it's set up, you're going to see that the build process is different. If I click Build Project, you're going to see that CMake is invoked before make is invoked. So this is invocation of make in a console, but I have access to the CMake configuration. So you can see that CMake has run on this project and configured the cross tool chains, all the environment before the actual make. So if you are developing with CMake, if that's how you manage your build process, because one of the differences between CMake and let's say this multi-C program here is that the in case of this multi-C program, toolchain is managed by or makefile is managed by the IDE. In case of CMake type of project, makefile is managed by CMake. Okay, and it's which auto generates makefiles. Just like with standard C projects, I can import a CMake-based project here as well. There's plenty of wizards available for importing projects. There's a dedicated wizard to import CMake project. And you can see here, I can associate it with the SDK. I can now browse to an example CMake application, select it, and next, associate the SDK and finish. So at this point, I've just imported a CMake project that was written outside of this program. You can see that this CMake project comes from, there are those icons that represent that this is tracked source. But at this point, I can build this project. Which results in an executable binary student. I can then run this application. I can debug this application the same way. Created an entry for it associated with a target. Boom, let's run it. And so this is how fast TimeStorm operates with project setup, switching between tool chains, switching between properties for different tool chains. Okay. We only had 45 minutes. I'm already over my time today. I'm going to stop here and see if there are any questions. If you're interested in more in-depth navigation through TimeStorm, something that is relevant to your project, to how you do development of your application software, please do not hesitate to contact us. We're more than happy to set up a private session with you and go over specific features and functionality of TimeStorm. So let me take a look at the questions. Again, you can ask your questions in the chat panel. It's on the left-hand side, typically. And there's one question I see here. Can TimeStorm be used for development of user interface applications, such as Qt? And so my answer to this is today, TimeStorm is used for C, C++ development. We do not offer any specific plugins for Qt software development. We recommend actually that you use the Qt creator for the Qt part. Everything else, C, C++ code can be developed with TimeStorm. There's another question that I can see here. Can TimeStorm be integrated into another Eclipse-based development environment? And yes. So if you have another IDE that's Eclipse-based, that's based on the similar Eclipse version and the primary C development toolkit version, you can integrate the two tools. And please contact us. We'll provide detailed guidelines on how to do it. So I don't see any other questions.
Thank you, Mache. Thanks for another great session. There's a lot of valuable information that you've provided the viewers with today that they can use for developing their applications. For those of you, I know I mentioned it last week, but I'll go ahead and reiterate it again today. If you'd like to further explore TimeStorm, you can do so in two ways. You can register for a free Linux-like account, which will allow you to generate a 30-day license, and you'll be able, with that license, you'll be able to unlock every feature of TimeStorm. So you can try everything out and give it a try. And I'll chat that link to everyone real quick here. And then you can also find YouTube videos here on our Timesys YouTube channel. We have TimeStorm videos in a TimeStorm playlist. Right now, I believe there are 5 videos. We have plans to add at least 4 more within the next week or two. So feel free to, we encourage you actually to go ahead and register or subscribe to our YouTube channel. I do see one more question here, Mache. I'm guessing you're still online. Are the kernel module samples the same as LKM's device drivers?
Yes. So loadable kernel modules building a device driver. Not every device driver can be built as a loadable kernel module, but when you do development of a device driver from scratch, loadable kernel module is the easiest way to start. So yes. We're going to address the system-level development, device drivers, Linux kernel configuration in session 3 next week.
Wonderful. Great, thank you. And as Mache mentioned, if you have any questions, please feel free to contact us. You can reply to any of the emails that you've been receiving, the reminder emails, and or as I mentioned, you will receive a follow-up email. So you can go ahead and reply to that if you'd like. We'll get back to you and answer your questions and get back to you as quickly as we can. I believe that's everything for today. So on behalf of Mache and myself, I want to thank you again for joining us. We'll see you all next week for session 3, system-level development and debugging with TimeStorm. Until then, everyone, I hope you have a great day. Thanks again for joining us.
Thank you.